Good afternoon, everyone. So let's start with the third video of our playlist. Okay, in the previous video, we have discussed about monolithic and its pros and cons, right? So now let's start with our microservices architecture and its pros and cons and what the features it's having and other things. Okay, so here I have created a basic diagram of the microservices architecture. Okay, and I'm going to give an overview of each the entities which are present here, right? So let's start with our this entities. Okay, so here's a client and he made an request to a endpoint. Let's say it's endpoint of like feed, right? He needs to get all the feeds here, right? So if you see here, when endpoint has been requested by a client, then firstly it will go to an entity called API gateway. Okay, so you can consider this gateway as your house or home gate, right? In order to enter your house, you need to just bypass via a gate. Okay, in normal cases, not in case of thieves and other stuff, right? And after the passing API gateway, so if someone is there, ring a bell, and you check whether this that particular person, you known unknown. If there is known, you let him enter into your home, right? If not, you just discard and say like, I don't know you, I can't let you enter. Same in the case of API gateway also, right? When you request any endpoint or any service, right, it will first go to the API gateway, and API gateway checks all the things like if this particular API have token or not. If it this API is having token, so whether it is a valid token or valid signature or not, and whether they have proper headers or not, and all those stuff checked by API gateway. Okay, another thing what API gateway do is the service discovery, like uh, so if you here there is a slash feed. Okay, so this endpoint and this feature must be rely on any of this servers which is reside behind the API gateway, right? So let's say this is the our server, okay, which is having a feed service, right? So it will first go to the API gateway client, and now the API gateway will have all the addresses of the servers, and like uh, destination address, like if this endpoint comes where I need to route the request, if this endpoint comes up, so where I need to route the request, right? So this is how the API gateway works. And once you put at this endpoint, the API gateway will do the first the service discovery. What it do in case of service discovery, like in the slash feed, it will first check the health of a server or service, right? Like whether this particular service which having the feed functionality is up and running or not, right? Whether and it's the database attached to this particular service is working fine or not. Okay, and if anything goes wrong, let's say database goes down or any server goes down, right, it will simply revert back and tell the client that the currently there is service which you are requesting is not available. Okay, okay, so the and another thing is the authorization of the API. It's also done by API gateway also, and it also acts as a reverse proxy too for the client and all this for servers, right? So let's start here. So let's start with the pros of this particular architecture, right? So if you see here, it's having a different servers, and each service is having a dedicated database, right? So if let's say it will give us many independent qualities too. Independency in the sense of there is a developer, right? Let's say there is a developer and he knows Python language and he wants to develop the same the feed service in the Python language, so he can do and deploy the service on a feed service server. And then there is a developer who know the Node.js, right? So he can write his service, let's say profile service in Node.js. And there is a developer who know in a Golang, he can write and deploy the services in Golang, right? If you say here each services are independent to each other. So in the microservice architecture, decoupling is the most important factor which we need to consider, right? If we don't decouple the services, what will do, we are not properly following the microservice architecture, and if anything goes wrong, the coupled service will also go down, right? So if you see here, it will gives us freedom to use different servers with different databases and with different language, right? So let's say if this particular service goes down, okay, so what will happen, it won't be impacting all over our application, right? What it will do when the users will go to request on the feed service, it will simply say it is not available for right now, but the other services will be up and running, right? And if you see here, it can be easily scalable in the sense, if you need to add any particular new service or anything, right? Let's say in feed there are three keys are coming in: name, profile picture, and the profile picture and the age of the user. And I also want to add like how many followers are following that particular user is having feed. So in this case, I need to only alter this feed service, not to do the changes in other services, right? Because this is particular decoupled, right? And we can also like instead of let's say the feed will be a very heavy busy service, right? So instead of like scaling or adding multiple services to all the services, we can only just scale easily with the feed services, right? Because it is an independent entity, right? Okay. And you might also think like what if the API gateway goes down, right? So in this case also, there is a many techniques, right? So there, one of the technique is like we have two API gateways, okay? So one is in active state, right? And one is in inactive state, right? So what they do, the active and inactive state, right, both share their heartbeat to each other. It simply means like this API gateway knows the status of this API gateway, right? And this API gateway knows the status of this API gateway, okay? And somehow this this API gateway goes down, right? So what it will do, both are bounded by the virtual IP, and it automatically the next request will be like coming up. Let's say if a request is coming up and this API gateway goes down, okay? So they both share a heartbeat of each other, and when the request is coming, this API gateway will give a signal to this, like I am going down, please be active, okay? So what it will do, the request which will be coming to this API gateway will be routed to this API gateway automatically, okay? So this is known as active passive gateway management technique, okay? And another thing also can be done, like we are having two API gateway in parallel, right? And there will be one request is coming, so it is handled by this API gateway, and one request is coming, this will be handled by this API gateway, okay? So this is known as technique of active API gateway management, right? So these things can be done. So these were the pros of this microservices architecture. Let's talk about the cons, right? So if you see in the diagram, right, there are a lot of databases coming up here, right? Lot of services are coming up. Okay, so there will be, if there are more services, okay, so there will be more deployment, users will be needed, more deployment techniques will be deployed in order to deploy each individual services, right? And it's very hard to debug also, right? In order to, if there is something wrong is coming up, you need to check first the API gateway, like what response you are getting, right? And then you need to check on that particular service. But in case of monolithic, if you remember, all the code is lies on a single server only, okay? You just need to go on that particular server and just debug whatever the issue is coming. But in this case, you need to check that particular service code and what went wrong, right? And it's if you see here, let's say in generally we decouple the services, right? But if you see if the feed services need to call any other service, right, the intercommunication, what we say in case of intercommunication of microservice, like the feed services need to call the profile service to get some data, right? In that case, for the communicating you need to install a TLS certificate in both of that, right? Right, which is a transport layer security. Okay, so they both can have a HTTPS uh, communication, and along with that there's some kind of security checks should also be maintained when both services are intercommunicating, right? And it will also increase the latency. Let's say the client has requested for the feed service, and feed it will go to API gateway, then the API gateway will go to the feed service, and the feed service is now intercommunicating with profile service. So if you see here, the first latency will be like here, then there will be intercommunication, then there will be latency here, right? So it will also increase latency. But in case of monolithic, if you remember, all the things relies on a single server only, right? So in case of monolithic, you just need to call that particular function, but in this case you need to make a HTTP request to other service, and first you need to do service discovery to whether that particular service you are going to call is active or not. And if it is active, then create a HTTP call and have a TLS handshake first, so both can connect and share their responses, right? So these are the basic pros and cons in the uh, microservices, right? It's have pros as well as sub cons too. Okay, so I would suggest, like, before jumping into microservices, all things should be considered first, whether you actually need this architecture or not. Okay, if you there's a very large team developing on working on a project, so in that case microservices can be a better option. And if you are like implementing there is a case of using multiple databases, like some things are working on SQL, NoSQL, Redshift, and all other different databases over it. So that can be all in that case also microservices will be useful, but uh, it's not very easy to implement. Okay, so before moving on to this architecture, or must decouple your services, right? List down whether you really require this thing or not. Okay, and once you are sure, like you are sure about this, right, then only do it, because over engineering is never a good option for any product or any product. Okay, so I will be ending this particular video on this only, and please do like, subscribe, and comment if there any feedback from yours, or any way I can improve my videos too. Okay, and thanks for your time. We will connect with you on next video. Thank you.